Countdown.
Tahniah! Siaran langsung ini dibawakan khas kepada anda oleh Akademi YouTuber Malaysia. Sebuah inisiatif e-didik Malaysia dan Kelab Guru Malaysia. Tumpukan perhatian anda. Siaran langsung akan bermula sebentar lagi. Link sijil akan diberikan di hujung siaran ini. Pastikan diisi dalam tempoh yang ditetapkan. Terima kasih.
Assalamualaikum dan salam sejahtera. Okay, hai semua guru, ibu bapa yang dihormati dan para pelajar dan cikgu kasih sekalian. Okey, selamat datang ke Pusat Tuisyen YouTuber AYU sesama e-didik Malaysia dan Kelab Guru Malaysia. Okey, bermula percuma selamanya percuma. Okey, untuk mendapatkan keberkatan kelas kita pada petang ini, mari kita sama-sama memulakan kelas dengan bacaan umum kita Al-Fatihah dan doa masing-masing. Okey, apa khabar para pelajar semua? Okey, harap semuanya berada dalam keadaan baik, bersedia nak teruskan kelas kita pada petang ni. Okey, jangan lupa jaga SOP. Okey, cikgu percaya semuanya tak sabar nak ikuti kelas kita. Okey, petang ni. Okey, cikgu perkenalkan diri dulu. Okey, cikgu Nik Mawar Hanifah binti Niasan atau Cikgu Mawar Kimia. Okey, dari Kuantan, Pahang selaku moderator pada petang ini. Okey, hari ini kita ada kelas tuition kimia pra-AYU. Okey, kita bersiaran langsung dari channel Teacher Lau Chaiwi atau Teacher Vivi Lau. Okey, sesiapa yang belum subscribe Teacher Vivi Lau, okey, jangan lupa tekan butang subscribe sebagai sokongan kepada Teacher Vivi Lau. Okey, untuk makluman, okey, nama penuh beliau Teacher Lau Chaiwi dari SMK Tinggi Kelang. Okay, tajuk akan disampaikan oleh Teacher Vivi Lau ialah Alkenes. Okay, Alkenes Okay, pelajar dan para penonton dialu-alukan untuk mempelajari topik berkenaan. Okay, kelas ini akan berlangsung lebih kurang 1 jam macam biasa. Okay, bersama kita juga Cikgu Tang, iaitu yang mengajar kimia matrikulasi dari Kolej Matrikulasi Selangor sebagai control host. Okay, and then okay, kami bertiga je pada hari ni. Okay, sebelum kita teruskan kelas, okay, cikgu nak ingatkan lagi sekali pelajar yang nak hantar komen, okay, gunakan bahasa yang sopan. Okay, and then fokus pada isi pelajaran. Okay, jangan lupa jawab soalan kalau ada soalan. Okay, and then nanti macam biasa akhir siaran kita akan hantar link ECJ. Okay, dan macam biasa kita ada 30 minit je lah nak isi maklumat tu. Okay, and then okay, before that kita ada kod macam biasa, kod untuk kita untuk pelajar take note, iaitu yang pertama okay, A2. Okay, A2. Okay, tanpa buang masa lagi, okay, cikgu serahkan kelas kita kepada Teacher Vivi Lau. Okay, Teacher Vivi, silakan.
Okay, good morning students and teachers. Thank you Teacher Mawar and Teacher Tang for being with us today. Today I'm going to go to the topic Alkenes. So let's start. Okay, so before I begin the lesson, let me introduce myself. First, my name is Lau Chaiwi. I'm currently teaching in Pusat Tingkatan 6 SMK Tinggi Kelang. And here is my channel Vivi Lau. And this is my pre-U Maths T and Maths M teammate. And we have biology team, which is led by Cikgu Faiza, and physics led by Puan Rosmaya, and accounts and economy led by Madam Fizi. And last but not least, we have chemistry led by Cikgu Shannon.
Teacher Vivi, I can't see your slides moving.
Oh, cannot see my slide. Okay, sorry.
Can share.
Share.
You can slideshow.
Oh, so now can see. Okay, I share the slide.
But not in the slideshow one.
Can you see now?
Yeah, a little bit smaller.
Still a little bit smaller.
I got slideshow kot.
Okay. So where first? So I share again.
Teacher Vivi Lau, you try to share again. You try to share
Yeah, I'm
back to
trying to share.
yeah, share again. Yeah. Share entire screen.
Can you see now?
Okay, wait.
Okay, so can you see now? So
Not yet. It
oh,
doesn't.
still cannot see.
Yeah.
Oh, so I share entire screen.
Oh,
Okay,
yeah,
okay.
yeah, yeah. Yes, can already.
Can see already.
Very good.
Yeah.
Yeah.
Okay,
You
so
can proceed.
so let's begin our lesson. So today we're going to learn about alkenes. So the functional group of alkene is carbon-carbon double bond. And alkenes is unsaturated hydrocarbon. So you can see the picture here. So unsaturated fats actually is unsaturated fatty acid, okay, with the carboxyl group and rubber bond, okay. So unsaturated fat is good for our body compared to the saturated fats. So general formula of alkenes is CnH2n. So the N smallest alkene is 2 carbon because you need a rubber bond. So each carbon atom has hybridization of sp2, okay, in the rubber bond. And due to the rubber bond, alkenes has cis-strand isomers because of the restricted rotation of the rubber bond. Okay, so here we have cis-strand isomer. You have learned before that introduction of organic chemistry. So here we do some revision. So cis isomer have the hydrogen atom on the same side, and the alkyl group on the opposite side. Okay, then trans isomer have hydrogen atom on the opposite side. So you can see there. So we look at the hydrogen atom. Okay, so trans opposite side, the hydrogen atom. Okay, then the properties of cis-strand isomers. The cis isomer is polar. Okay, because of the CH3 at the same side. So more electrons at the same side. So here become partial negative and here partial positive. So make the cis isomer polar molecule. Then trans isomer is non-polar. Okay. Then melting point of cis isomer is lower because of the shape of the cis like this. It's more difficult to Gaussian pack in the solid structure. So it has a lower melting point. So trans isomer has higher melting point. Then cis isomer, because it's more polar, it has stronger van der Waals forces, so it's higher boiling point compared to the trans. Okay. Then solubility in the neutral solvent, cis isomer more polar is more soluble. Okay. So we look at the nomenclature. Okay, so here we have example of the alkenes. So we have aliphatic alkene here. Okay, so we have ethene, propene, cyclohexene in the cyclic structure. Then if you have triple bond is ethynes. Okay, then you have 5 carbon pentynes. Okay, so the nomenclature is you remove the suffix of alkenes ane with ene. Okay, so alkene has ene. Okay, then step 1 you have like Cikgu Shannon and teacher Kong taught you before, always determine the longest carbon chain with the functional group. So the functional group here is rubber bond. So determine the parent chain. Okay, so step 2, give the lowest number to the functional group rubber bond, and then number the substituents and name the substituent as a prefix of the alkene according to alphabetical order. Okay, so we look at this example. So this one, 4 carbon. Okay, parent chain is butene. Okay, then the rubber bond at the first carbon, so 1 butene. Okay, or you can name as put 1 in. Then if you have 5 carbon here, then functional group at the second carbon to pentene. Okay, then substituents. Okay, so substituent follow the functional group. So it's the third carbon. So 3 methyl, 1 pentene. Okay, then okay, this one. So you can see here. You can go this way, go this way is longer side. Okay, so you must go this way. Find the longest chain. So this way is 7 carbon. Okay, so it's second carbon atom is the functional group. So 2 heptane, then you have 1, 2, 3 substituents. Okay, so follow alphabetical order. So 4 ethyl, 3, 5 dimethyl, 2 heptane. Okay, so the one is for aliphatic alkenes. Then we look at cyclic alkene. So cyclic alkene, the naming also the same, just because it's a cyclic structure, so you use like the cycle alkene, you use cycle names. So determine the parent name also parent chain. So cyclopentane, this one is 5 carbon, 1, 2, 3, 4, 5. So cyclopentene. Okay, then the carbon rubber bond always 1 and 2, so you no need to write 1 cyclopentene. Okay, then substituents also number after the functional group. Okay, and the prefix follow alphabetical. So we look at example. So this one cyclopentene, then with the substituents, okay, and the same carbon, 3,3-dimethyl cyclopentene. Then follow alphabetical order, 1 amino, 2 cyclopentene. Okay. Then next one, if we have 2 rubber bonds, more than 1 rubber bonds. So let's say 2 rubber bond here. So you also the same determine the parent chain, longest carbon chain with rubber bond. Then also give lowest number to the rubber bonds and the substituents number and name according to the alphabetical order. Okay. So example here we have first carbon and the third carbon with the rubber bond. So it's 5 carbon is heptene. So hepta. Okay. So 5 carbon penta. Okay, pentane. So 1,3 pentadiene. Then the second one. Okay, find the longest chain. Okay, 1, 2, 3, 4, 5, 6, 7. Okay, so first carbon and the third carbon rubber bond. Okay, so this one is heptadiene. So it's 1, 3 heptadiene. Then you have branch, second carbon and the 4 carbon. So follow alphabetical order, 4 ethyl, 2 methyl, 1, 3 heptadiene. Okay. So far, any question? So if you know question, you look at this question. So you try to do now. Question number 1. So we have, this one is a skeletal formula for this. So if you don't write the CH3 also can skeletal formula. So if you don't want to write this one also can. Means you just draw a line here also can.
Okay, maybe Teacher Vivi can show first.
Oh, I show
Can't
first.
see any
Yeah,
answer
so
yet.
we have no answer yet. So we have you find the parent chain first. 1, 2, 3, 4, 5, 6 carbon. So hexane, okay. So first carbon, third carbon is the rubber bond, huh? So this is a diene, huh? Okay, 1,3 hexadiene. Okay, then you have substituents, okay. So 1, 3, 4, 5, huh? So 5 methyl, okay. So the answer is 5 methyl 1,3 hexadiene, okay. 5 methyl 1,3 hexadiene. Okay, you try for the second one. So the rubber bond always the smallest number, remember. So 1, 2, 3, okay. Okay, we look at the second one now. So see how many carbon for the hexene, cyclohexene. This one at US. Okay, any answer from the student for the second one?
So far not yet, Teacher Vivi.
Okay. So you count the number of carbon of the cycloalkene structure. Okay, so name the parent name, then you give number to the substituents, and name the substituent according to the alphabetical order. Okay, any answer?
Not yet. We don't have any answer.
Oh, okay. So I share the answer with you. Okay, so this one is 1, 2, 3, 4, 5, 6 carbon. So it's cyclohexene. Okay, so only one rubber bond, cyclohexene. Then we have methyl and bromine. So we follow give the smallest number to the rubber bond. Okay, so you have to give smaller number to the substituent also. So you go this way, you don't go this way.
We got one answer here, Teacher Vivi.
I'm going to answer. Okay, what is the answer?
From Bun Long Lim, 5 bromo,
Okay.
3 methyl cyclohexene.
Oh, okay. So 3 methyl. Okay, very good. So give the smallest number to the substituent also. So 5 bromo, 3 methyl. Okay, correct. So 1, 2, 3, 4, 5. You don't go this way. Don't go 1, 2, 3, 4. So no 4 bromo. It's 5 bromo. Okay. So very good, Bunlong. So we look at physical properties. So physical properties of alkenes. Alkenes are insoluble in water. Okay, because it's non-polar. Okay, and soluble in polar organic solvents. Then it has densities less than water. Then the melting and boiling point also normally lower than the alkane with the same number of carbon atoms. Okay. Then alkenes with 2 to 4 carbon atoms are gases at room temperature, and the unsubstituted alkenes with 5 to 17 carbon atoms are liquids. Alkenes with more than 17 carbon atoms are solid. Okay. Then the straight chain alkenes has higher boiling point than the branch one, because straight chain alkenes has larger surface area for the formation of van der Waals forces. So have stronger van der Waals forces than the bunch isomers. Okay, so we look at the table. So these are the values for the boiling point. So boiling point increases when the number of carbon molar mass increases, stronger van der Waals forces. Okay, so solubility increases because the non-polar hydrocarbon chain getting longer. Okay, the boiling point increases going down the series. Okay. Okay, so we look at preparation of alkenes. Okay, so you can prepare alkenes by dehydration of alcohols. Okay, remove the alcohol with the rehydrating agents, concentrated sulfuric acid, and heating, or dehydrogenation of haloalkenes. Okay, so we also can call elimination. This one. Okay, and so elimination. Okay, so we remove the hydrogen halide. So the chemical reagent used is alcohol ethanolic potassium hydroxide, okay, KOH in ethanol. Ethanol is a solvent. Okay, so these two. Okay, so for the dehydrogenation or elimination, here we use Sedif rule. Okay, so Sedif rule is used to determine the dominant products in the elimination. Okay, so the major product is always the, okay, use this one. Okay, the major product is always the alkene with the greater number of alkyl groups bonded to the rubber bond. Okay, so that's why your major product, if you have these two, the major product will be this one with the more number of alkyl groups. Okay, so we look at chemical properties of alkenes. Okay, so alkene, because of the rubber bond, presence of rubber bond, this rubber bond is a nucleophilic site, okay, which is rich of electron. So this nucleophilic site is prone to be attacked by the electrophiles. So electrophile is like positive ion, it will attack the nucleophilic site. Okay, so that's why alkenes undergo electrophilic addition because of the rubber bond is unsaturated, so you can accept atoms, okay, to become saturated. So it's electrophile attack. So it's electrophilic addition reaction. Okay, beside electrophilic addition reactions, alkene also undergo oxidation or oxidative cleavage, broken of the rubber bonds. Okay, then alkene also can undergo addition polymerization. Okay, so we use Markov-Nikov's rule to determine the major products. Okay, so this one is actually related to just now the Sedif rule. Okay, so means for the Markov-Nikov's rule is for the electrophilic addition. Okay, just now is elimination. So the major product is the hydrogen atom must added to the carbon. Okay, so added to this carbon with more hydrogen atom. So let's say you have if you have hydrogen halide react with the alkene, so the hydrogen ion will added to the carbon with more hydrogen atom. Okay, instead of this carbon with alkyl. Okay, so the reason is because of the stability of carboxyl ion. Okay, so the carboxyl ion will be stabilized by the number of alkyl group. Okay, so the alkyl group is a electron donating group, as you learned before. So it will stabilize the positive charge here. Okay, electron donated to the positive here, so it become less positive. So stabilize the positive carboxyl ion here. Okay, so the more the alkyl group you have, okay, the more stable is the carboxyl ion. So tertiary is the most stable, followed by secondary, primary. Methyl is the least stable. Okay, so that's why your hydrogen must added to this carbon, so it will form alkyl group here. Okay, so stabilize the carboxyl ion. Okay, then we have example of electrophilic addition reaction. Okay, so for alkane you need to know hydrogenation. So we have hydrogen reacted with the alkene in the presence of catalyst, platinum, nickel, palladium. Okay, then halogen also can have reaction with halogen halides. Example, we have halogen chloride or halogen bromide, or react with the acidified water. This one hydration to form alcohol. And the halogens, okay, halogen two types. We have inert solvent and water. This one will produce different major products. Okay, so if in the inert solvent, CCl4 will produce dibromo, okay, libromo or glycol alkanes. Okay, if you have water, then you will have alcohol produced also, okay, beside the halogen. Okay, so example, we look at the reaction. Okay, so halogen added, so all are electrophilic addition here. Halogen added to the carbon double bond, you have alkanes, okay, form. If halogen chloride and or halogen bromide react with the alkanes, you will have halogen chloride, okay, chloroalkane, haloalkane, chloroalkane, and bromoalkane. Okay, so the name for this one is 2-chloro. Okay, so give the smallest number to the substituents. Okay, 2-chloropropane. Later you will learn haloalkanes. Okay, then if you have chlorine in the inner solvents, okay, so you will form glycol, okay, glycoloalkanes. So one here is 1,2-glycholopropane. Okay. So far, any question?
Not yet. We don't have any question.
Okay, thank you. So I continue with the next one. So if you have chlorine in the water as a solvent, so means this one is chlorine water. Okay, or they will say chlorine water, chlorine aqueous. Okay. So or bromine water or bromine aqueous, then you will have different major products. Okay, so you have OH instead of Cl, you will have OH bonded to the one of the carbon atom of the rubber bond. Okay, as a major products. Okay, so if you have Br2, then OH-Br. Okay. Okay, then if you have halogen chloride or halogen bromide, then one is bonded to the I think this one's before they got same one. Okay, so this one I skip. Infant already have. Okay, so you look at this one. This one infant already have. So we look at the next one, hydration. So so reaction of alkane with the acid. Okay, so lactic acid. So we have water as a reagent. So the acid become the catalyst. So acid is a catalyst here. Okay. Okay, so you have two examples here. So you can have either a catalyst of phosphoric acid or concentrated sulfuric acid. Okay, so both will form alcohol. Okay, so for the H3PO41, you have to memorize the condition is 300 degrees Celsius, 60 atmosphere. Okay, then for the second one, okay, you have concentrated sulfuric acid is heating. Okay, so actually for the concentrated sulfuric acid one, involve of a few steps in the reaction. So I write here. So for this one, so step one is concentrated sulfuric acid first. So it's 0 to 15 degrees Celsius. You have to memorize. Okay, so alkenes react with the concentrated sulfuric acid. Will form the alkyl halogen sulfate first. Okay, OSO3H. Okay, then only second step, only add the water. Okay, water heating. Okay, then form the alcohol. Form the ROH. Okay, so it's very short form. Okay, 2 steps. Okay, so beside alcohol also can form two hydroxy group. So two hydroxy group, one we call it as diol. Okay, so we have two reagents to be used here. You can either use oxygen silver followed by dilute acid, or you can use alkaline KMnO4, called alkaline KMnO4. Okay, so if you use oxygen silver, also you will form the two step also. You will form the epoxy ethane first. Okay, so at first you will form this one before it form the final products diol. Okay, it form this one first. So right here. So form this one first. Okay, then followed by water. Okay, you add water. Acidify, okay, or dilute acid, only form the alcohol, okay, from the OH. Okay, so this one is oxygen silver. Okay, so if alkaline KMnO4, straight away from diol. Okay, so this one is actually not electrophilic addition. Okay, this one is electrophilic addition, but for this one, diol is reaction with the alkaline KMnO4 is the oxidation. Alkaline KMnO4 in the core temperature or room temperature is a weak oxidizing agent. Okay, so it just formed diol. If strong oxidizing agent like the acidified KMnO4 or the acidified potassium dichromate 6, it will form the carboxylic acid. Okay, so we look at the oxidation or
Teacher
reaction.
Vivi,
Yes.
can we stop for iklan first?
Okay, so I stop here.
Okay. Yeah, thank you. Before that, I want to share the next code. 02. Okay, 02. Okay, Teacher Tang.
Tuisyen online percuma. Tuisyen online percuma. Layari www.academyyoutuber bagi mengikuti tuisyen online secara percuma. Prasekolah, sekolah rendah, sekolah menengah, semua ada di Akademi YouTuber. Rujuk jadual di laman sesawang www.academyyoutuber.com. Semoga masa terluang anak-anak anda diisi dengan sebaiknya. Tuisyen online percuma, mestilah Akademi YouTuber.
Okay, Teacher Vivi, you can proceed now.
Okay, thank you. So I continue with ozonolysis. So oxidative cleavage of rubber bond, we have ozonolysis and oxidation. So these two, we can use these two reactions to identify the position of rubber bond. Okay, position of rubber bond in. Okay, so we look at the first one. So the reagent for ozonolysis, we have ozone O3, followed by zinc in acidic medium, or you can use light metal sulfur. Okay, so the ozone will break the, okay, that's what ozone and the zinc will break the rubber bond here. Okay, so you just add the oxygen here. Okay, add the rubber bond, so you will form two metal. Two aldehyde metana. Two metana molecules. So if you have unsymmetrical, you have out here, so you will form one is RC double bond OH, both are aldehyde. So aldehyde, this one is metana. Okay, then if you have, okay, this one, okay, you will symmetrical, so you will form two the same one. Okay, RC double bond OH, so it's actually the same thing. Okay, then next example, if you have this one, okay, so you will form C double bond OR, okay, and this one, so this one is ketone, okay, so just now aldehyde, okay, this one aldehyde, okay, so if you have this one, O alkyl group, so you form both ketones, okay, so we look at the next one. Okay, so identify the position of rubber bond in the alkenes. So you can use organolysis reaction to products of the organolysis reaction to determine the alkenes. Okay, so to do that, first you have to place a carbon rubber bond oxygen to meet with each other. Okay, so put the two oxygen side by side. Okay, then you remove the oxygen atoms. Okay, then you join up the rubber bond, join up the two structure by connecting the rubber bond. Okay, so only have keep one rubber bond. So then you copy the other things. Okay, copy the R and R apostrophe here. Okay, so you will give the alkenes. Okay, so by using the products, you can products of the organolysis, you can get the alkene structure and know the location of rubber bond. Okay, example question 2. Okay, you try to do this one. Okay, so we have we write in the rubber bond structure so you can see. Okay, so you write the rubber bond structure. So you put the oxygen side by side. Okay, so you try to do now. So the CH3CO is actually C double bond Oleh, okay? And the CH3 here is the aldehyde, so it's C double bond OH. Okay, any answer?
Okay, we don't have any answer yet.
Okay, so because it was difficult to write in the comments,
Correct.
so
I think so.
answer, I will give you answer. So remove the oxygen atom. Okay, then join up the rubber bond with one rubber bond. Okay, so you will get this one and just copy the alkyl groups, okay, and the hydrogen atoms. Okay, so you will get this one is 1, 2, 3, 4, 5, 5 2 pentene, 2, 4, okay, 2, 4 limethyl, 2 pentene. Okay, then we look at oxidation reaction by strong oxidizing agent. Okay, we can have acidified KMnO4 or acidified potassium glycomate 6. Okay, so the condition is heat or reflux, so you will get alkene back completely. Okay, so you must remember there are three conditions. So the first condition is when you have the carbon of the rubber bond at the end of the alkenes, they will form carbon dioxide and water. Okay, then second condition, if you have okay, the alkyl group bonded to the carbon, you will form carboxylic acid. Okay, with one hydrogen atom, you will form carboxylic acid. Okay, so this one is carbon rubber bond at the end of the alkenes, so carbon dioxide and water. Okay, this one is 2 carboxylic acid form. Okay, so carboxylic acid. Okay, so back at the rubber bond. Okay, so here's two conditions. First condition is carbon at the end of the alkenes. Okay, or at the carbon rubber bond will form carbon dioxide and water. If the rubber bond carbon will have the hydrogen atom with alkyl, one alkyl group will form carboxylic acid. Okay, third condition is when you have two alkyl and no hydrogen bonded to the carbon rubber bond. Okay, so you will form ketone. Okay, so it cannot further oxidize. So form ketone. So just now form carboxylic acid. Okay, so this one will form carboxylic acid. Okay, so carboxylic acid. Okay, then the last one, okay, two ketones. Okay, so we look at this question. Write the oxidation products when the alkenes are treated with acidified KMO4 solution. Okay, so we look at the A first. Okay, so A, you can see which condition is fulfilled. Okay, so it has a alkyl here and this one alkyl. Okay, so this one you will look at the rubber bond. So means this one will form two carboxylic acid. Okay, that's why will give you the answer. Okay, then the second one. Okay, you have a carbon atom at the end of the alkene. So means this one will form carbon dioxide and water. Then here is got one alkyl. Okay, so one hydrogen, so it's a carboxylic acid. Okay, so carboxylic acid and the carbon dioxide and water. Okay, any question?
Okay, so far we don't have any question.
Okay, so I continue. So we look at the mechanism here. Okay, so the electrophilic addition mechanism for alkenes. Okay, so this is a reaction you learned just now. Okay, HBl added to the carbon rubber bond. So you get the bromo alkenes. Okay, so in the mechanism you must show the electron movement. This one you learned before. Okay, so the hydrogen bromide is polar molecule. Okay, so the bromine is more electronegative. Okay, so when they go near the rubber bond, okay, so the rubber bond is rich with electron. Okay, it's a nucleophile here. So because of the bromine is more electronegative than hydrogen, so two electrons go to the Br. Okay, so it will make the hydrogen positive. Okay, so the rubber bond will attack the hydrogen. Okay, so the two electrons go to the, so this one first. Okay, then second, two electrons go to the hydrogen. Okay, so the hydrogen will, in the end, join combine, share the two electrons with the carbon here. Okay, so it first is a CH3 C positive carbocation is formed. Okay, so the hydrogen always go to the carbon. This one you learn in Markov-Nikov rule. The hydrogen must go to the carbon with more hydrogen atoms. So hydrogen go to this carbon. Okay, and instead of this carbon, so we will have one alkyl form. So it will stabilize the carbocation. Okay, becomes secondary carbocation. So stabilize. So if your hydrogen added to this carbon, okay, added to this carbon, so means you only have CH2 here, so it's not stable. Okay, so the major product will be this one. This one is a major product. So in the exam, normally you write major products unless the question asks for you to write all the possible products. Then for mechanism, you always write for the major products. Okay. So this is a slow step because you take time to break the bond here. Okay, so Bl negative come out just now. So the Bl negative is not stable. It will join with the unstable carbocation. Okay, so two electrons move from the Bl negative to the carbon positive. So this is a very fast reaction. So in the end, you form the two bromopropane. Okay. So if you have hydrogen bromide, you write carbocation positive like this. If you have Bl2, you have to roll like this. Okay. So like just now, Br is non-polar. Okay, but when the Br2 molecule go near the rubber bonds, okay, it will polarize the Br2. Okay, so 2 electrons from the covalent bond go to the partial negative bromine here. Okay, after polarized by the alkenes. Okay, then the Br positive, partial positive here will be attacked by the rubber bond. So 2 electrons go to the Br positive here. Okay, then the Br share electron with the carbon. Okay, so it will form this carbocation structure. Okay, so you must draw 2 lines. Okay, then the Br negative will donate the electron to the carbon. Okay, carbon here. So it will become okay. So this one donate to the here. Okay, and the 2 electron here, the electron go to the Br here. So it will form Br negative. Okay, Br negative join with this carbon, so you form Br here. Okay, so CBr and CBr here. So 1, 2, like bromopropane. Okay, so it's a fast reactions. Okay, any question for this one?
Okay, nak ni Teacher Vivi.
Okay, so I go to the unsaturated test. Okay, so you have learned just how the formation of diol. So sometimes we have to do test to differentiate the hydrocarbons. Okay, so unsaturated test is to differentiate saturated and unsaturated hydrocarbon. Okay, to distinguish is to differentiate alkene and alkenes. So we can use a Bayer test. So this one you have learned just now. So Bayer's test the reagent is called alkaline KMnO4. Okay, or you can just write KMnO4/hydroxide ion. So it will form the diol and manganese dioxide. So the observation you will have for alkene, for this one is for alkene. You will have alkene recolorized purple color of KMnO4. Okay, you also can write brown precipitate form. Okay, but most important is this one, purple color recolorized. Then for alkenes, it's no visible change. Okay, so in the exam you always write out the reagents, the conditions, the equation. Okay, for the differentiation test and the observation. Okay, for both. So one must have no visible change. You cannot write no reactions. Okay, second test is you use bromine in CCl4. So also recolorization occur. So this time is the bromine, reddish brown color of bromine become colorless. Then for alkane also no visible change. Okay, this one should be number 3. Then last one is bromine water. So bromine aqueous. So you will have yellowish brown color of bromine water change to colorless. Then for alkane is no visible change. Okay. So now we go to the last part of the lesson today. So we go to addition polymerization. So this one I go faster because you will learn polymerization at the end. Okay. So alkene can undergo polymerization because of rubber bond. So it's called addition polymerization because of rubber bond. So polymerization also have condensation, but for alkene it's addition polymerization. So we have example, we have polypropene, polychloroethene, polyphenylethene. So the polymer always write the monomer in the bracket. Okay, so the monomer is in the bracket one. Okay, then you need to know the chemical equation. So like M more of monomers form the polymers. So the polymer always have the bracket N. Okay, then repeating unit always in the bracket one. No N. No write N. Okay, so single repeating unit you write one time. If double repeating unit you write 2 times. Okay, then you have to know the users. Okay, so here I just list out 2. Okay, then second example is polychloroethene, or we call polyvinyl chloride. Okay, so PVC. So this is a polymer and the equation, and this is a repeat unit and the users. Okay, that's why we have phenyl-ethene. Okay, and phenyl-ethene reacts and form the polymer polyphenyl-ethene. Okay, the repeat unit, single repeat unit. Okay, and the users. So these are the examples. The diagram. Okay, so this one is the plastic put in the to repair the joint. Okay, then this one is enforcement plastic in the aquarium. And the PVC pipe. Okay, so we look at the question. You try to do this question. So which of the following statements about 2-methyl but-2-in is correct? So A, it exhibits geometrical isomerism. Okay, second, ozonolysis of the compound use ethanoic acid as one of its products. C, it reacts with alkalines, potassium manganese 7 to form a diol. D, it produces carbon dioxide gas when it is heated with acidified potassium dichromate 6. So which is the correct answer? So maybe you can try write out the structure to help you see. Okay, so but-2-in. So you want to know whether cis trans occur. So you wrote out the structure. 2-methyl. Okay, 2-methyl. So this one is 2-methyl, and this one halogen. Okay, so is A correct?
Okay, student, you can try to answer the question. Just put A, B, C, or D. We have Bun Long Lim here, Chia Yao, Chia Ying. You can try to answer the question.
So you have learned cis-trans isomer before, in the intro of organic chemistry. So for cis-trans to occur, the carbon and the rubber bond must fulfill what condition? Must have opposite, right? Must have different structure of bonded to the carbon rubber bond, right? So these two are the same, So definitely this one is wrong, okay? So geometrical isomerism wrong.
Got answer here, Teacher Bibi?
Got answer.
Bun
Yeah.
Long Lim. Answer C.
Answer C.
Yeah.
C or D?
Long Lim. Answer C. Cat.
Oh, C. Okay, very good. So C correct. So okay, alkaline potassium manganese 7 form diol. Okay, answer C correct. Okay, so A is wrong. Okay, so B also ethanoic acid. CH3C.
Okay, Chia Ying also answer C.
Okay, so B also correct. Okay. No, B is ozonolysis. Ozonolysis. No, this one is not strong potassium manganese 7, not acidified, so cannot. So this one wrong. Okay. Ozonolysis should only get the ketone. For this one is aldehyde. Okay, get aldehyde. Okay, D produce carbon dioxide. So it's wrong. Okay, so must have rubber bond at the end of the alkene. So this one wrong. So very good. C answer correct. Okay, then we look at question 5. Which of the following is not true of both cis and trans 2-butene? So this one last question for today. Cis and trans. So number one, both compounds have the same dipole moment. Number two, both compounds use the same products when ozonolized. Three, both compounds produce the same product when treated with bromine in CCl4.
They have no ABC teacher Vivi.
This one actually the ABC is how many correct? Let's say A is 1 correct, B is so I straight away give you 1, 2, 3. Okay, no need to choose a ABCD. You just write whether 1 correct, 2 correct. Okay.
Yeah, just put number lah, 1 or 2 or
Yeah,
3 or
that's why
1
the
or
number.
2. Just put the number, which one
skip
the
the
correct one.
ABCD.
Which one is not true? Not true.
Choose a not true one. Remember, not true one.
Okay, let's answer the last question for today. Okay, Bun Lonely answer 1 only for not true.
1 only. Okay, very good. So 1 is the answer. Okay, because cis is more polar. Okay, that's how we learn. Cis is more polar because of the structure like this one. CH3 here. Okay, cis is more polar. Okay, because more electron focus at one side. Okay, so here is more polar. Here is less polar. Then for where else for the trans, the shape is more spherical. So it's non-polar. Trans is non-polar. So the answer 1 is wrong. Okay. Then 2 because cis and trans they are same thing. They are both 2 proteins, so they will have the same products. So this one is should be same products, correct? Okay. Then they will have produced the same product when treated with bromine and CCl4 also because they are 2 protein. Okay. They just have different structure only. Okay, so let's
You
all
also
continue.
answer 1. Okay, thank you. Congratulations for Long Lim and Chia Ying for the answer the last question just now. Okay, thank you. Terima kasih kepada teacher Vivi Lau. Okay, atas pengkongsian ilmu yang banyak tadi banyak yang bermanfaat. Okay, selesai kelas kita pada petang ini. Okay, sebelum kita tamatkan sesi secara langsung, okay, mohon tutup ruangan chat, klik butang subscribe yang masih merah, aktifkan ikon loceng. Okay, supaya kita tak terlepas kelas lah ya every week. Okay, and then kita boleh share, klik like, share kepada rakan-rakan di media sosial, FB. Okay, and then seterusnya, okay, link sijil link sijil kita tengok. Okay, teacher Tang dah share link sijil. Okay, boleh dapatkan pada bahagian chat. Okay, link tersebut akan tamat dalam tempoh setengah jam selepas live ini. Dan pastikan anda guna email e-didik sahaja. Okay, dan jangan lupa untuk dapatkan jadual tuition online terkini melalui portal www.academyyoutuber.com serta dapatkan info-info terkini. Okay, bantu cikgu untuk sebar luaskan kelas tuition percuma ini kepada rakan-rakan guru-guru seluruh Malaysia. Okay, sebelum tu terima kasih diucapkan kepada teacher Vivi, teacher Tang, okay, atas kelas hari ini. Semoga kita mendapat manfaat daripada kelas-kelas yang dijalankan. Okay, sebelum tu cikgu nak share last code kita pada petang ini iaitu 76. Okay, 76. Okay, last code. Okay, akhirnya terima kasih kepada semua. Okay, segala yang baik daripada Allah dan yang terdapat kekurangan, kelemahan daripada kami sendiri. Okay, kelas tuition online percuma berakhir sudah. Di lain siaran, berjumpa lagi. Bye-bye semua.
Bye.
Wow, banyaknya hadiah menarik menanti anda. Wah, kini Akademi YouTuber mengambil inisiatif baru di mana memberikan hadiah-hadiah ini secara percuma. Ya, percuma kepada anda semua. Bagaimana caranya? Dengan mengikuti kelas tuition online percuma Akademi YouTuber sambil mengutip mata kredit, anda dapat menukarkannya dengan hadiah-hadiah yang menarik ini. Tunggu apa lagi? Segalanya percuma.
Jangan lepaskan peluang tau. Dah dapat banyak hadiah menarik, takkan nak lepaskan peluang.
Layari www.academyyoutuber.com sekarang untuk maklumat lanjut.
Dibawakan kepada anda oleh Akademi YouTuber.